Okay. So we're going to go through the questions together. I'll post the solution. I'll post the solutions as well. Okay. So for the first one, right, you want to know if each equation, oh my goodness, that should be equation. I'll fix that. We want to know if each equation defines y as a function of x. You know, that's what we want to know. Okay. Okay, so the way, the way I did it, the way I told you to do it, that is you really want to sketch the graph of the function, like, you know, in Desmos, and see if it passes the vertical line test. Well, this is the graph of x times y equals -1. These vertical line segments, so to say, I put in as extra. But you can see, though, that the graph passes the vertical line test. It's similar to the graph of x times y equals 1, which gave us y equals 1 over x. You know, hopefully you can see that. And as you get closer to the y-axis, I know it looks like it's not going to pass the vertical line test, but it does, though. Okay, well, now let's get y in terms of x. So we're going to do that now. That's not so bad, actually. It's just basic algebra. So to get y in terms of x, we have x times y is -1. We want to get y all alone. So we divide both sides by x, and we get y equals -1 over x. The negative was with 1, right? We had -1. I put the negative in front. So it's the same thing. You can do that. Keep in mind also that x is not 0, right? The equation is x times y has to be -1, right? But so you can't have x equal to 0. That's impossible, because 0 times anything is 0. So what I did over here is legit. For x equals the absolute value of y, I mean, it's not hard to graph that. Let me just show you quickly. You can graph it easily in Desmos. If I can get up, there it is. All right. So let me do this. So let me cancel that. So for this, you could just do x equals, and you have the absolute value here. You could type in y, the absolute value, and there you go. And basically, and this is the graph we get, as you can see. So we have x equals the absolute value of y. Okay, that's good. But hopefully you can see from here, and really from the solutions, which I'll post again. I will post them on Blackboard. Here we go. I did draw a black line segment, as you can see, you know, which really is a line, I guess, but it intersects the graph twice, as you can see, right? And because it intersects the graph twice, this graph fails the vertical line test. So y is not a function of x. Y is not a function of x. So we don't get y in terms of x here. I mean, I don't think you can anyway from this, so, okay. All right, any questions on this? Okay, for the next one, let me see, can everyone see that? Yeah, okay, good. Just want to make sure everyone can see it. This you probably didn't have to graph because this is an equation. Excuse me, the graph of this is a non-vertical line. And as I said last time, any non-vertical line is the graph of a function. In other words, it will pass the vertical line test. So this equation does define y as a function of x. I mean, I drew some vertical line segments just to illustrate that, but again, any non-vertical line will pass the vertical line test. Now for this, we want to get y in terms of x. So how do we do that? Well, again, you just solve for y in terms of x. So let's get x out of here. We want to get y all alone. So we subtract 3x from both sides. That's what I'm doing, right? And we get negative 5y equals 15 minus 3x, which I rewrote down here. Okay. Now, and again, we don't want negative 5y, we just want y, so we divide by negative 5. Notice I'm dividing both terms here by negative 5. I don't remember if students have done this, but I know it's an easy mistake to make where you just divide 15 by negative 5 or 3 by negative 5. You want to divide each term by negative 5 here. Doing so, you'll get y on the left equals negative 3 minus minus becomes plus 3x over 5. And now we have y in terms of x, so we have y as a function of x. Okay, are there any questions on that? Okay, well, let's keep going. So here we want the domain of each function, right? Okay, so here we have 1 over 5x plus 2. Wait a minute. Something's wrong there. No, negative 5x plus 2. I'm sorry. That's what that should be. You know what? Let me get this up. Let me just quickly fix that. That should be a negative 5x plus 2. Crazy. Well, easy to fix. All right. Okay, you know what? Let me actually share the Word document because I just fixed it. All right. I don't know how I missed that. Here we go. All right. Okay. Maybe this will do it. Trying to get the minus sign bigger, but it's not letting me for some reason. All right. Anyway, we get negative 5x y equals 1 over negative 5x plus 2. Okay. So again, you have it in the denominator, right? So the domain we know is going to be all x, such that the denominator is not 0. What's the denominator here? Negative 5x plus 2. So we want to know when negative 5x plus 2 is not 0. Well, let's first determine where it is 0, and then we'll just say the domain is everything else. And if you go through this calculation, right, it's an equation we're solving. As you can see, we subtract 2 from each side. Negative 5x we get is negative 2, okay? Then we divide both sides by negative 5, right? And so we get x equals 2 over 5. All right, you know what? Let me stop here anyway. So the domain is everything except 2/5. So I'll post the solutions when I can. So remember, the test is due tomorrow before 11:59 p.m. So if I don't hear from you, have a great day, everyone.
Thank you.
You're welcome. See you later.
Have a nice weekend.
You too. There we go. All right, let me fix that.